Good morning or good afternoon, and welcome to our webinar on new features of JDK 17. Simon Ritter will present this webinar. He's a Java champion and Azul's deputy CTO, and he's been involved with Java since the very beginning when he joined Sun in 1996. And at Oracle, he was the head of the Java Technology Evangelism team. He joined Azul in 2015. There will be time for questions at the end of this webinar presentation, so please submit your questions via the question menu option in the control panel, and Simon will address them at the end of the webinar. This webinar will also be recorded and will send you a link to the recording sometime during the next few days. That email will also contain a link to the slide deck that Simon will be going through during his presentation. So let me pass over control to Simon now. Simon, why don't you get started?
Thank you very much. Yes, indeed. Good morning, good afternoon, good evening, depending on where you are. As Stefan said, we're going to be talking about JDK 17. And because this is a new long-term support release, what we're actually going to do is we're going to go through all the features that have changed since the last long-term support release, which was JDK 11. And because there's a lot of changes, what I'm going to do in this webinar is I'm going to focus on changes to the Java language itself. I did this presentation a little bit earlier for the European audience, and one of the things that came across in terms of the questions was that there's probably a need for another webinar, which I will organize, where we talk about things that are not the language changes. So we'll talk about the changes to the libraries, talk about the changes to the JVM, and so on. But for this particular presentation, we're just going to focus on what's changed in terms of the syntax of the Java language. Now, the first thing that we need to think about is the fact that this is a long-term support release. And as I said, it's the first one since JDK 11. That is significant because it means that the providers of OpenJDK binary distributions, whether it's Oracle, whether it's Zulu from Azul, whoever, we are committing to providing continued updates for a period of time so that you can deploy this into production and continue to maintain a level of security and stability for your Java runtime for your applications. So the important thing to get across there is that there is a distinction between the OpenJDK source code and binary distributions. OpenJDK projects deliver the source code for each Java version, but it's up to the maintainers and the people who contribute to that as to how long those changes get made. For the binary distributions, that's where people commit to doing a certain period of time. One of the other things that's interesting is that last week, when JDK 17 was released, Oracle also made an announcement with a proposal to change the time between long-term support releases. When they made this change back at the time that JDK 9 was released, they said that we would have 3 years between LTS releases. JDK 11, JDK 17, 6 releases, 3 years. What they've now proposed is to change that to a faster cadence where we'll only have 2 years between long-term support releases. What that means is JDK 21 will be the next long-term support release, not JDK 23. I think this is a good idea because of the rate of change that we're seeing in terms of the Java platform. It means that there's the idea that developers really want to take advantage of these changes and the new features. And because most corporations, most enterprises want to only deploy those ones that have long-term support, it's quite a long time to wait for 3 years. So now what we can do is we only have to wait for 2 years. So something to consider, something to think about in terms of the deployment. What I'd like to do then is to start by asking you, the audience, a question. So let's do a little bit of a poll. And the question here is, how soon do you plan to deploy JDK 17 in production? When are you going to start running your enterprise applications, your mission critical applications on JDK 17? And I've given you 4 possible answers. First of those is immediately. You've actually deployed some applications on that, you're rolling it out straight away, a couple of weeks time, you're going to have it in your data center. Second one is that you may be a little bit more conservative. You may decide to wait 6 to 12 months. You're interested in waiting for a couple of updates just to make sure if there's any sort of key things that need to be addressed in terms of stability, that those have been put into the updates. So you're going to wait a little bit of time. Third option, Okay, you're going to wait a bit longer, so more than a year, and possibly, how much your use of the LTS is going to be debatable. And then the last option is that you don't actually have any plans to move to JDK 17 at all. And I put in brackets there, JDK 8 is great, because what we do see is there are a lot of people still using older versions, JDK 8, JDK 7, even JDK 6, and they don't really want to move off them because, well, it just works. So if we can just give a couple of seconds, and then I think probably had enough time to answer the question. So if we have a look at the answers to that, what we'll see, interesting. Yes, okay. So as I said, I did this presentation this morning and the numbers were slightly different, but in terms of the distribution, it was pretty much the same. Small number of people who are deploying immediately, only 5%. Majority of people are looking at 6 to 12 months. That's very understandable. A third of the people longer than 12 months, and 15% no plans to move at all. So really, the majority of people are looking to move either now or within sort of 6 to 12 months. So I think that's very understandable given that the audience for this webinar is going to be people who are interested in JDK 17. Okay, so let's move on then. And as I say, the idea is to go through all the changes that have happened since JDK 11. Very logically then, we'll start with JDK 12. Now, one of the things that we're seeing here is, as I put in brackets here, preview. And this is quite important because with a shift to the 6-month release cycle, what it's allowed us to do is to enable the ability to have preview features and incubator modules. This is two things where what we can do is we can introduce new features into the JDK in a way that, although they're complete, as in they've been fully developed, they're not beta testing, there's not lots of work going on in terms of bug fixing, they're ready to go and you can use them in production. But it's the idea that we don't put them into the standard straight away, with the idea that we can actually make some changes based on feedback from developers. And we'll see how that works as we go through it. It's been a very useful thing. I think this is a great idea. First of these is switch expressions. Now, if we look at Java, the language, it was based in terms of the syntax very much on the C programming language. One of the things you had there was switch statements. The idea that you could switch on a variable and then you could have different cases for the values of that variable and then do different things. Kind of like a multiple if then else type of construct. Now, this is all very good and it works very well, but it does have a couple of sort of issues from the program point of view. One of the things is that you have to have every case statement separated. So you've got case A, case B, case C. Second thing, more importantly, is that you've got to remember to put a break statement for each block of cases that you deal with. Now, you don't have to put a break statement in, it's perfectly valid syntax, but that's designed so that if you don't do it, it falls through to the next set of case statements. Most of the time, you don't need to do that. And if you forget to put in your break statement, you end up with a situation where the value you end up with is not what you expect, and it can be a potentially hard bug to find. Similarly, scope of local variables, sometimes not always as intuitive as you might think. If we look at a very common pattern of usage of the switch statement, this is a good example. What I'm doing here is I'm taking a variable called day and switching on it. Now that contains the day of the week, and what I want to do is to assign a value to number of letters based on what the value of day is. So this idea that we've got one value that we're switching on, and then we're going to assign something to another value. Clearly, in terms of our code, we've got case Monday, Friday, Sunday, and we assign number of letters to be 6, case Tuesday at 7, and so on. As I said, in terms of potential for problems, if we forget to put a break statement in those case blocks, then we drop through and we might set the value to be incorrect. Similarly, we might forget to put an assignment for number of letters in one of those case statements, and then we get an inconsistent value and we get problems with what's going on. In JDK 12, we introduced the idea of a switch expression. It's the same idea as a switch statement, but a statement is where you're executing a piece of code, but it doesn't create a result. An expression, you execute a piece of code, it generates a result which you can assign to a variable. Immediately, that solves one of our problems. Because we can assign the result of the switch expression to number of letters, we're doing that once. So there's no issue of forgetting to do the assignment. As we can see, the code is a lot simpler in terms of the number of lines involved. What we're doing is we're saying, okay, we'll switch on day, same as we did before. We'll assign the result of that number of letters. Then we've got our case blocks. And again, we can take advantage of a very powerful feature that the developers found, which is a comma separated list, where we can say case Monday, comma Friday, comma Sunday. Now, I must say that, being a little facetious, I can't understand how it took us 25 years to figure out that we didn't have to have a case statement on separate lines. But, there you go. What we've then done is borrow some of the syntax from the Lambda expression and use the arrow as an operator to say that the right-hand side of that arrow is the value that will be returned by the switch expression. Monday, Friday, Sunday, we return 6. Tuesday, we return 7, and so on. That reduces the amount of code that we've got quite substantially. It reduces the number of lines, and it all looks great. The important thing about this is that even though we've reduced the number of lines of code, we haven't lost any of the readability. In fact, I would actually say it's even more readable than it was before. And that's really the important thing. We don't want to lose readability of code by adding these new features. So that's about a switch expression. The other thing we can do is we can actually combine the old style syntax with the new style of doing a switch expression. So in this case, we still maintain the same separate cases on different lines, but in terms of returning the value from the switch expression, rather than using the arrow operator, in this case, what we need to do is we need to say break 6 or break 7. This will work from the point of view of the syntax of Java because you can use break in, well, now you can use break in 3 different ways. Firstly, you could use break from a switch statement. Secondly, you could use break with a label where you're breaking out of a loop. And now you can use break in a switch expression to indicate which value you're returning. There is no confusion from the compiler's point of view between a break with a label and break with a value that's being returned, because a label can't start with a number. So the compiler can quite easily determine which break is being used in that case. We'll come back to that a little bit later on. JDK 13, logically, the next release. So what have we got there? What we have here is another preview feature. Pretty much everything that we're seeing in terms of language features is now preview rather than being introduced directly into the language. And the idea here is the idea of text blocks. What we want is a simpler way of being able to create a string literal in Java. We've always been able to do this using double quotes, but the problem's been if you wanted text to go across multiple lines. There was no simple way of doing that. You needed to use escape characters, you needed to use concatenation, things like that. What text blocks does is allow us to use a different way of specifying a string literal. And what we've done here is to borrow some of the syntax from Python. We use 3 double quotes. 3 double quotes indicates that we have a string literal, but in this case, it's a text block. That means everything after the 3 double quotes is going to be treated as part of our string, whether it's new lines, whether it's special characters, it doesn't matter. Everything up to the next set of 3 double quotes is part of our string. If we wanted to put 3 double quotes inside our string, we could do that, but we would have to escape by putting a backslash in front of at least the first one. You can do the first one, second one, the third one, but you have to put an escape character in front of at least the first one. Now, if we print out the result of what that produces, what we'll see is that our HTML tags that we've got in our text block are indented in the way that we want them to. So we've got the opening and closing HTML tags, we've got body tags, and we've got a paragraph tag. And we can see the indentation is correct. But if we look at the code above, what we're not doing is including all that white space on the left-hand side. If we thought about it logically, we might have to push all of our tags over to the left-hand margin to ensure that we got the alignment the way that we wanted it to. But that's not very good from a readability perspective. So in this case, what's happening is that there is this idea of incidental white space. The first character on the left-hand side is treated as where the left-hand margin is going to be, and everything to the left of that is stripped out. This incidental white space, which is used to make our code more readable, is removed. Second thing that we need to be aware of is that in terms of our three double quotes, the opening three double quotes, you must have a new line after that. You can't put the opening HTML tag directly after that on the same line. So you do actually need a new line before you start your body of your text block. The third thing we need to be aware of is that if we were to put some space, some white space, after the closing HTML tag that I've shown here, before those three double quotes, that actually gets stripped out. Now, I'm not really sure about the reasoning for that, but the decision was made that that was what's going to happen. So if you looked at the individual characters that were generated in that output, those spaces that are after the HTML tag would be removed. Now, what we can do is we can say, okay, we actually do want some padding on the left-hand side. We want to move it away from the left-hand margin. And to do that, we can move the closing three double quotes onto the next line, and we can push them further over to the left to indicate what we need is some intentional indentation. Here we've got 4 spaces of intentional indentation, and then we've still got a certain amount of incidental white space. When we print out the results of that, we'll see that our HTML tags are now indented in the way that we expect them to, but they're shifted over to the right by the amount of the intentional indentation. One small thing that happens here is because we've had to put the 3 double quotes, the closing ones, on the next line, we end up with an additional blank line, which we might not want. But again, I'll come back to that in a moment. Switch expression. Hang on, I've talked about the switch expression already. Why am I talking about it in JDK 13, having talked about it in JDK 12? Well, the answer is that this is a perfect example of why we have preview features. People looked at the suggestion of how this syntax works, this idea that we can use break with a number to indicate the value that's going to be returned from the expression. And they said, you know, yes, the compiler can differentiate between break with a return value and break with a label, but it's introducing the possibility to make it harder to understand what's going on, harder to read the code, and we don't want that. So the developers said, you know what, you're right. What we'll do is we'll change the way that we do that, and rather than using break, we'll use yield. So now we're going to yield 6, yield 7. That makes it clear because now if we use break, we're breaking either from a switch statement or to a label. And if we're using a switch expression, we use yield and that returns a value. Question I got this morning was, well, does this mean that yield is now a reserved word? And the answer is no, it's not, in the sense that you can't use it as a variable name. Yield in this case is being used as a context-specific reserved word, so it's only recognized by the compiler when it's used in this particular case. You can still use yield as a variable name, not a problem at all. JDK 14. I think from my perspective, JDK 14 was one of the best releases recently because it did introduce a number of interesting features and very useful features. Let's talk about how we use data classes in Java. Often we need to encapsulate data in Java in a simple data class. So all we're doing is taking a set of values, putting them into a class, so we've got that encapsulation and access to it. Very simple example here, a class called point. In order to do that, what we need to do is create a new class. Call it point, and then within that we have 2 instance variables, x and y, both of which are doubles, and we'll make them final. Then we need to have a constructor, and we need to pass parameters to that constructor, which are the values of x and y. Within the body of the constructor, we have to assign the values that we pass in to the instance variables, and then we need to access our methods to return the values of X and Y when we need them. All very standard Java code, but just to create what is effectively a tuple, we have 14 lines of code. Lots of boilerplate code, and yes, the IDE can do a lot of this for us, but it's still a lot of code just to create a tuple. In JDK 14, we now have records. Again, preview feature, so potential for a few changes before it becomes part of the standard. Rather than having those 14 lines of code, now we can reduce that to 1. We can say, okay, let's create our record. We'll call it point. We'll use the same syntax in terms of the constructor to indicate that the values we want to store in that record are a double called X and double called Y. Now, a record is a form of class in the same way that enumeration is a slightly special form of class. So we have a set of braces because we need a body to that record. In this case, we're not doing anything special, so all we need is the code effectively that we saw on the previous slide. So we can leave an empty set of braces. The compiler will generate all of the code that we saw before. So it will fill in the details of the instance variables, it will create the constructor, it will create the accessor methods. Because we are dealing with what is essentially a class, we can make it generic. We could create a different record called anything, and we could provide a generic type parameter, t. And then we could say that the type of the thing that we want to store in our record, anything, is also of type t. And then we could put anything we want in there. That will work quite happily. Another thing we can do is we can add extra instance fields, but only if they're static. We cannot add any more instance fields if they're not static. The ones that we specify as the definition of the record itself are the only ones that we can make part of the record itself, unless they're static. Example here, I've created a record called a circle. It has a variable that we're going to store in there, which is the radius, very logically, and then we've created this static variable pi 3.142. What we can then do is add an additional method to our record, because it's like a class, so we can do that, and this one's going to return the value of the area. What it does is simply use our static variable, multiple pi r squared, and return the area. A few additional details about records. First of these is that the base class of all records is java.lang.record. And what that obviously means is that because it already has a base class, other than object, it means that we cannot subclass record from another class. Obviously, we can implement as many interfaces as we want, but we can't make a record a subclass of something else because it's already a subclass of java.lang.record. Again, because it is a class, if we wanted to, we can override the standard methods in object, equals, hashcode, and toString, and provide our own implementations of those if we want to. If we don't want to, we can just leave the compiler to generate this for us, but if we need specific versions of those, we can do that by overriding them. Records are implicitly final, meaning that you cannot extend a record further. You can't subclass it, just isn't possible. So records are kind of, as I say, a special form of class because you can't subclass anything else and you can't extend it further. They're just records. If you want to, you can add the final modifier to your record, but because it's already implicitly final, you don't have to do that. It won't make any difference. Interesting thing here is that the records do not follow the Java bean pattern. And by that, what we mean is that the accessor methods are the name of the variable that we're storing in that record. In case of our point, it's X and Y are the names of the methods to access the values of X and Y. If we were following the bean pattern, then we would use getX and getY. That initially, when records were introduced, was a little bit of an issue because some frameworks and libraries use the bean pattern to understand how to access data objects within Java. Because the records don't use that way of doing things, it did cause a little bit of an issue, but the frameworks and libraries have now caught up with supporting records, so that's kind of been addressed. Of course, as somebody pointed out to me on Twitter, there is a way around this problem, which is rather than calling your variable X and Y, call your variable get X and get Y, because that will then generate methods which are get X and get Y. It's a little bit of a kludge, but it does solve the problem. Constructors are quite important when it comes to records, because sometimes what we might want to do is to include some additional logic in terms of what the constructor does. We don't just want to pass in the values. We can do that in a couple of different ways. What we can do is use the canonical constructor, essentially the constructor that we would expect for the class which we've defined in being a record. So here what I've got is a record called T-Rex. I've specified the values that we want stored there are int X and int Y. I can create a canonical constructor by doing or creating the same constructor that I would normally in a class. Public T-Rex, pass in int X, int Y, put in the additional logic that I need to check whether X is less than Y, print out a message. But I have to remember to explicitly set the values of the instance variables to the parameters that are passed to that constructor. That sort of starts losing some of the benefits of records, because that boilerplate code that we saw being eliminated has now kind of snuck back in again. To get around that, what the developers have done is allow the use of a compact constructor. What we can do in the case of our record called range here, which again takes two ints, low and high, rather than creating the canonical constructor, we create a compact constructor which doesn't need the parameters passed to it. We already know what the parameters are because on the line above, we've got the record definition. We know it's low and high, both ints. We can include our additional logic, which says if low is greater than high, we throw a new illegal argument exception. And because we're using the compact constructor, the compiler will add the necessary lines of code to assign the values of the parameters passed in to the instance variables. So again, we're sort of shrinking things down, and this is a nice way of doing things. There is, however, one thing we need to be careful of, which is that in the case of the code here, I'm throwing an illegal argument exception. That will work, but I'm limited because the compact constructor, and in fact the canonical constructor as well, can only throw an unchecked exception. If I wanted to throw an exception of my own kind, which was checked, I can't do that because the syntax doesn't support the idea of a throws clause on either the compact constructor or the canonical constructor. Next thing is looking at how Java deals with understanding the specific type of a reference. Often we may have a method where we pass in a reference to an object, but we don't know what specific type it is. We know what supertype it is, but not what subtype it is. And right from the very beginning, we've had the instance of operator. So we can test an object reference against a particular type. If we look at this piece of code, this is very, very typical. It's exactly what we do all the time. We say if obj instance of string, then the first thing we have to do if we want to use it as a string is to create a new variable, string s, and we have to assign that to the reference obj, but we have to do an explicit cast to tell the compiler that it's a string. So we do that every time. Then when we want to use s, we can do that by calling length on s because we now have a string reference. In JDK 14, we now have a new feature called pattern matching on instance of. Again, it's a preview, so we can have potentially changes in that. One thing I should say, should have mentioned this at the beginning really, is if you want to use preview features, you can do that very easily, but in order to comply with the idea of write once, run anywhere and the standardization of Java, you have to enable preview features both at compile time and at runtime. So you have to turn those on with the command line flag, and in fact at compile time you also have to specify which version you want those preview features enabled for. In this case, what's happening is we're doing pattern matching, but not in the regular expression way of doing things. This is matching against a type and then creating a reference to that based on the type. If we look at what we're doing here, we can say if obj instance of string, but then we also specify s. And s is essentially the variable name that we're going to reference that obj as if it is a string. In the true branch of the if statement, clearly we do have a string, so the scope of s is valid, and that means that we can reference s and call the length method on that, and that will work quite happily. If we look at the false branch, the else, because it isn't a string, obj is not a string, then s is not valid in terms of its scope, and if we try to reference s and call a method on it, then the compiler would reject that, and we get an error. We can be a little bit more clever with this, and we can do something like this. We could say if obj instance of string s, we then use the AND operator and say s.length is greater than 0, do something. Now we know that with the AND operator, the left-hand side is always evaluated first, and only if the left-hand side evaluates to true will we evaluate the right-hand side. If the left-hand side evaluates to true, we know we have a string, so the scope of s is going to be valid. So when we call s.length on the right-hand side, that will work, and we can test against greater than 0, and the code will compile. If we try to use the OR operator, that won't work, because again, we understand how Java works, and we know that we will evaluate the left-hand side of the operator, and only if that equates to false will we evaluate the right-hand side. So if it equates to false, we know that obj is not a string, and therefore the scope of s will not be valid on the right-hand side, and we couldn't call length on that. So we'll get a compiler error telling us that we can't do that. In pattern matching of instance of, we use what's called flow scoping. And so sometimes we need to think a little bit carefully about how that scoping works. In this case, what I'm saying is if and testing O instance of string s, but then inverting that. So we're doing not. If not O instance of string s, then we return from the method. What that means is that after that, the effective else branch of the if statement is the rest of the code in the method. And that means that s will be valid for the rest of the method. So sometimes it's maybe a little bit less than obvious where s, in this case, is valid in terms of its scope. Text box. Again, this has now been updated, and we have a second preview in JDK 14. In terms of changes, 2 minor things were added, essentially escape sequences. First of those was the idea of having a backslash at the end of a line to indicate that you wanted continuation and you didn't want a new line between those two lines. This is good because it solves that problem we saw in the first example, where when we wanted to introduce some intentional indentation, because we moved the 3 double quotes onto the following line, like we've done here, by putting a backslash now at the end of that final line, we eliminate the problem of the extra blank line. So that's good. Second thing that's happened is because the developers obviously saw that people had this question about the the elimination or stripping of trailing spaces, what we can now do is use a \s to indicate that yes, we do want trailing spaces on those lines. So we can do that using our the way that well, we use \s in this example. JDK 15. Again, looking at the Java language and the way that it works, we have an object-oriented language, meaning that we have inheritance and we have a type hierarchy. Here, I've got a very simple example where I've got class shape and I've got 3 subclasses of that: triangle, square, and pentagon. Now, what we can't do is control from shape, previously to JDK 15, how we could have subclassing of that from specific methods. The only thing we could do to control that is to mark it as final, meaning that no other class can subclass shape. In JDK 15, what we want to be able to do is introduce the idea of sealed classes. Sealed classes, again, preview feature. Everything's a preview feature at the moment. And what it allows us to do is to control which classes can subclass a particular class. The idea behind this is that if you create a class and then you subclass it and you have control over that, that's all very good. But there might be other people working on the project that you're not interacting with on a daily basis, and they look at your class and they say, yeah, that's great, I want to use shape, I'll use that in my code over here in a completely different package, completely different module. That's fine, it works, but then you come along and say, you know what, I'm going to change the way shape works a bit and do it in such a way that I know that that will work with my subclasses, but somebody else who's used it somewhere else then isn't aware of those changes, and suddenly their code behaves differently and it's all difficult to maintain. So this is the idea of being able to have more control over who can subclass. You can think of final as being the ultimate sealed class. One interesting thing about this is that sealed classes also applies to interfaces. And it was one of the things that I learned was that an interface is actually a form of class. I didn't know that before, but it is the case. How we use this, firstly, we have to understand that all classes that are sealed and all of the subclasses have to be within the same package or module. So they have to be reasonably closely located. How we use that is by adding some additional syntax. So here we've got our class shape and we're adding an additional modifier, sealed, which tells us that this class is sealed. And then we add a permits clause, which specifies the classes which are allowed to subclass from shape, triangle, square, and pentagon. That means that our code will compile, everything will work in the way that we expect it to. If somebody else would come along and decide, I like shape, I want to subclass that with a circle, the compiler would reject that, create an error, because circle is not listed in the permits clause of our shape class. When it comes to the subclasses of a sealed class, we have to specify the inheritance capabilities explicitly of each of those. And there are 3 different ways of doing that. So we can look at examples of each of those. The first of those is that we can continue to make the subclass sealed and specify further subclasses that are allowed to inherit from that. We use the same syntax we saw before. In the case of our triangle, we would say sealed class triangle, add a permits clause, and say that the equilateral class and isosceles class are allowed to inherit from triangle, which extends shape. The second thing that we could do in terms of specifying the inheritance capabilities is to prevent any further subclassing. In the same way that we used to at the moment, we could mark square, for example, as being final, so it can't be extended any further. And then the last thing that we can do is to say that this class, subclass, is going to be unsealed. And we do that using a new keyword, if you like. It's a restricted keyword, which is non-sealed. A modifier on class pentagon, so in non-sealed class pentagon, which means that anybody can now extend that. Has to be said, there was a great deal of discussion about whether we should use hyphenated keywords in Java, and the decision was definitely that we should, because it means that it allows us to extend the syntax a lot further. One of the great things about hyphenated keywords is that they don't have any impact on backwards compatibility, because you can't use a hyphen in a variable name. Records were given a second preview in JDK 15, and a couple of minor changes here. First was that the fields within a record, the instance variables, are now truly really final. Now you might think that because they're marked as final that you can't change their value. There's no mutator methods, there's no set method with a record, so you couldn't actually change the value. But the thing is that with reflection in normal Java, you can still change a final variable. If you try and change a records field with reflection, it won't work. You'll get an illegal access exception, can't change it. I think that's a really good thing to do. Second thing they did was they said that native methods are now explicitly prohibited. Again, a record is a class, so you could theoretically put a native method in there with JNI. And the reason they gave for that was that it could introduce behavior that would be dependent on external state, and they didn't want that because record is just a data class. It's supposed to be immutable. Shallow immutability for records. Obviously, if you've got object references as the values you store in there, those things cannot be changed, but the values within the objects it refers to can be changed. So it's shallow immutability. The other thing they did in the second preview of records was to introduce the idea of local records, which is, I think, really good. What this allows us to do is to put a local record within a method, and it is implicitly static. The other great thing is this now also applies to enumerations and interfaces. So you can use those within methods as well. Good example here. What I've got is a method which takes a list of people who are selling things for me and a particular month. And what I want to do is to order that list of sellers by how much they sold in a particular month. Now I could do that using streams, I could do that, but it's going to be fairly complicated in terms of the code that I generate. By using a local record, I can simplify that very nicely. I have my local record, which is called sales. That has two things in it, so tuple. First is the seller. Second is how much that seller sold in a particular month. What I then do is take my sellers, create a stream, map from the stream of sellers into a stream of sales records. And I do that by taking the seller and then calculating how much they sold in the month that I'm interested in. So I've got those two values into my local record, create a stream of those, and then I sort them based on the value of what they sold in that month. That creates me a nice stream of my local records. I can then map back from that, from the local record, into the seller contained in the record. So I've got my ordered list of sellers based on how much they sold in that month. Collect it into a list, return it, and I've got what I want. Simple code, nice and easy, doesn't lose any of that readability. The other thing with records in terms of the second preview, because of the introduction of sealed classes, what will happen is that records can now work with sealed classes in the form of interfaces. Obviously, we can't inherit from anything other than Java lang record, but we can implement other interfaces. So we can create a sealed interface called car in this example, which permits two sub interfaces, red car and blue car. So now my record is red car and blue car, which implements car, and everything will work as we expect it to. JDK 16. Now, JDK 16 from a language point of view really didn't do very much. That doesn't mean that JDK 16 as a release was didn't have very much in it, because there was lots of other things related to APIs and the JVM and even the build infrastructure. But from a language perspective, only a couple of things changed. First was that pattern matching of instanceof became a final feature. Same with records. In the case of records, there wasn't anything that got changed between 15 and 16. So they just said, yep, records are good. They're now final. You don't have to enable preview features in order to use them from JDK 16. Same with pattern matching of instanceof, but they did make a couple of minor changes. First of those was to say that the pattern variables that are used with that are no longer explicitly final. So that was something that was a useful change, I think. Second thing was they said that it was a compile time error to compare an expression of type S against a pattern of type T, where S is a subtype of T. You have to read that a couple of times to understand what it actually means because of the way it's worded. So I'll just show you an example to explain that slightly more easily. I've got a method called printColorPoint. It takes a rectangle R. I've then, within that, said if R is an instance of rectangle, use pattern matching instance of and assign it to the variable rect, and then print out whatever rect is. Obviously, the pattern matching on instance of is irrelevant, because if I'm passing in a rectangle, then it's always going to be an instance of rectangle. And the compiler will now reject that, and it will say, hang on, pattern type rectangle is a subtype of expression type rectangle, so you can't actually do that, and it will just reject it. JDK 17, bringing us right up to date. Pattern matching again, this time for switch. remember, this is about pattern matching on a type. So we've seen switch statements, we've seen the changes in terms of the switch expression. What we're now seeing is an extension to that. With the switch statement and expression, you're limited prior to JDK 17 on what type you could switch on. You could do integral values, you could do strings, and you could do enumerations. What they've done in JDK 17 is expanding that into the idea of type patterns being matched as well. So it's very much like the way that type pattern matching for instanceof works. As an example, I pass object O into my type tester method, and then I switch on O, and then I have a set of cases. Because I'm using a switch statement, I can actually use the newer syntax, even though it's not an expression. I can use the syntax for a statement as well. So here I can say, in the case of a null, print out it's a null type. Null is one of those special things. It's essentially it's an instance of all types. So we'll match null and say it's a null type. Then we can say, okay, is it a string? If it is a string, assign a reference to S so that we can use that on the right-hand side of the arrow operator, and we can print out what S is. Similarly, if it's a color, we'll assign a value to C, which is object O, and then we'll be able to reference C as a color and call get RGB on that and print out the colors. We can do this with arrays of primitives, because even though a primitive is not an object reference, an array is effectively an object reference. So it's a type. We can say case int array IA, so we're assigning the reference to IA, and then we can print out the length of that array, calling length on IA, and that will work. And then we also have a default if we've got something else. One of the things we do need to be aware of is that in terms of pattern matching for switch, we have to have completeness. What does that mean? Well, if I take this example here, where I've got my switch on O, and I say I've got a case for string S and a case for integer I. That's fine, except what if it's not a string or an integer? In that case, we don't know what to do, and the compiler will reject that because it's not a complete test against all the possible types. To solve that, we have to have a default case. So we say default, okay, do something else. That way we've covered all possible types that O could be. Now, that doesn't mean we always have to have a default statement. We could, if we're using a sealed class, make sure that we've covered all of the possible types, so we can have completeness. In this case, if I use the shape that we showed previously, we can say switch on shape, and we can have case triangle, case square, case pentagon. Those are all the possible subtypes of shape, so we know that that will work, and we actually will have completeness there, and the compiler will be quite happy with that. We can also use guarded patterns, and the idea here is that we can use the idea of testing against specific type, but then we can also have a conditional associated with that. Here what I'm doing is I'm again using my shape sealed class and saying, okay, I've got a case triangle T, but then I will add the AND operator and add a conditional that says if the area of T, because we know that it is a type triangle, so we can call area on that, and we'll test against it being greater than 25, and we'll say, yeah, it's a big triangle. If that fails, we don't know whether it's failed because it's not a triangle or whether it's not greater than 25. So we then have another case which says, well, maybe it is a triangle, but it's not greater than 25. If that's the case, we'll print out as a small triangle, and then we've got a case for square and we've got a case for pentagon. So that will still be complete, remember. Compatibility issues, just to kind of wrap up. If you're migrating from JDK 11 specifically to JDK 17, a few things to be aware of. JDK 14, the CMS garbage collector was removed. If you're still using that, then you should move to G1 or ideally Azul Prime, better way of doing garbage collection, but CMS is no longer there. JDK 15 removed the Nashorn scripting engine. So if you're running JavaScript from your Java application, then you need to be aware of that, and you would need to provide that through a different module. JDK 17 The experimental ahead of time and JIT compilers were removed. They were introduced, I think, in JDK 13. I'd have to check that, but they were introduced earlier with the idea of looking at whether that made sense. Not many people have used them, but just be aware that if you had used them in JDK 17, they've been removed. One other thing, JDK 17 deprecated the security manager for removal. So it didn't actually remove it, but it said that in probably the next release, 18, it will be removed completely. No, it doesn't make Java less secure. This is related to applets and the security manager for the sandbox, where applets ran within this constrained security environment, and you had to have specific permission if you wanted to access a network connection or a file or something like that. There are some situations where this might be a problem for people in the future, but this is still under discussion about how to resolve those issues, but just be aware that they have been deprecated. The other thing that has been addressed is the encapsulation of internal JDK APIs. So in JDK 9, the idea was to turn off access to all of the non-public APIs within the JDK class libraries. That didn't work because of the idea of backwards compatibility. So they introduced the illegal access flag, which had a default setting of allow, meaning you could still access all of the internal APIs without having to set a specific value to the flag. JDK 16 turned that off by default. So it set it to deny, meaning if you wanted to continue using those internal APIs, you could still do so, but you had to set the specific command line flag to enable that. In JDK 17, this almost completes strong encapsulation. The illegal access flag has no effect now, meaning if you turn it on or off or whatever, it won't do anything. It will give you a warning saying you're still using it, but it means that anything that's not a critical API is no longer accessible, regardless of what you try and do. Critical APIs, I think there are 9 of them, are things like SunMISC unsafe. So they are still accessible, and until we have a public API that gives us the same functionality, they'll still be available for code to use. Just to summarize then, say a few words about what we do at Azul in terms of our builds of OpenJDK. So we have Zulu builds of OpenJDK. These are our fully TCK tested enhanced builds of OpenJDK. We go back in terms of supporting all the way to JDK 6. So we have 6, 7, 8, 11, 13, 15, and now 17 supported with updates. In terms of platform support, very wide. We have the 64-bit Intel versions for Windows, Mac, and Linux. If you're using things like Windows XP, we also have 32-bit versions for Windows and Linux. And it is very much a drop-in replacement for the Oracle JDK. You can just move your applications. There are no compatibility issues. As I said, fully TCK tested, and we've never had, with many hundreds of customers who've made this move, any problems from a compatibility point of view. Just to conclude then, 6 months release cycle, I think, is working very, very well. The language is developing very nicely. We're seeing a lot of these things which are just taking those kind of rough edges off some of the language, making it easier, avoiding some of the boilerplate code, but maintaining that readability. That's the key thing for me, is maintaining that readability. I haven't had time to cover APIs, haven't had time to cover JVM features. I'm looking at doing another webinar that will cover those at a later date. As I said, Azul Platform Core for supported builds of Zulu if you want to use OpenJDK and deploy into production. So that's it for the slides. If you've got questions, feel free to type those into the question and answer box on the Q&A on the GoToWebinar, and I will now try and answer those. So we've got a couple of questions here. So, okay. Do you have to use yield in the concise syntax as well? No, so that's a good point. If you want to, there's 2 ways of doing the switch expression and switch statement now, which is you can either use the concise syntax where you use the arrow operator, or you use the old style syntax with separate case statements and the colon. If you use separate case statements and a colon, then you use yield to say which value you're going to return. If you use the arrow and the concise syntax, then you don't need to use yield, you simply put the value that you're returning. So that will work quite happily. Can record be used to return a tuple from a method? Would you put the record into a separate file then, or can you use local records somehow? Right, yes, so definitely you can use a record to return a tuple from a method, but if you want to use it outside of the method, then you can't use it as a local record. So you would have to have a separate record outside so that you can say, I want to return a record of, let's say, a point. So I'll return a point with my two values in it, but it would have to be outside of the method so that both the method that's returning the value and the one that you're returning it to understand what a record is. So the scope of that record would have to be applicable to both of those. Does Linux support include Solaris? Yes, it does, although I would say that Solaris is not Linux. Yes, in terms of what we do at Azul, we do have Solaris builds both for Spark and for Intel that you can get of Zulu. So yes, we would have those available for you. We've also got other things like MIPS and ARM32, ARM64, PowerPC. We've got a whole bunch of other things as well. So lots of different builds. Do you have any idea of what the Java version adoption stats are? How many are still on 8 versus 11? Yeah, I mean, if I look at some of the things I've seen, there was a JVM survey that was done by SNCC a little while ago, and that showed some interesting statistics where you can see that a lot of people are still on 8. The adoption of 11 has progressed, but it really is that jump from 8 to 9+, which is the big step for a lot of people. And that's because of modularity. It's because of the encapsulation of the internal APIs that has made a bit of a difference in terms of how easy it is to jump from 8 to 9+. But we are definitely seeing the adoption of 11 has been greater over the last, I'd say, sort of year or so. Internally, the local records become inner classes, or how are they compiled? Yes, I guess they would be, because essentially they are just a class. So the reference is to a class that's used within there. So yes, an inner class is essentially what would actually happen there. What is the difference between Azul OpenJDK, Zulu OpenJDK, and OpenJDK? There isn't any difference. Okay, let me explain that. OpenJDK is source code. So if you go to the OpenJDK website, you will find that there is a project for each version of Java from JDK 6 onwards. And what we do at Azul is we download the source code from the repository, we clone it, and then we will build that to generate what we call Zulu. Zulu is our binary distribution of the JDK, OpenJDK. So we provide that for free. You can download it from our website, but we also provide commercial support around that, which is what we call Azul Platform Core. So Zulu is the name of the distribution. Azul Platform Core is our commercial support of that. So essentially there are 3 different things there. There's OpenJDK, which is the source code. There's the Zulu binary distribution of the OpenJDK, what we built and you can run your Java applications on. And then we have the Azul Platform Core, which is where we provide you with the commercial support in terms of like the normal support organization and updates within a SLA and things like that. So I am bang on the hour and I don't see any more questions. So I would just like to say that I hope this webinar has been interesting, and thank you very much for listening.